Hello everybody, welcome back to our unit on circles where we are going to start checking out some problems with actual numbers using all the things that we know about angles and arcs in circles. So let's first talk about some things that we already know about circles that maybe aren't particularly fresh in our minds. So number one, the whole circle, if you're looking at a whole circle like we are over here, you're looking at 360 degrees. Okay, so in other words, if I put an axis, an XY axis here, we know that from here, swoop around, we know that's 180 degrees. And so if you come from here and swoop back around, that's another 180 degrees, right? So we learned a long time ago that a straight angle is 180 degrees, right? Well, a circle is two put together, right? It's all the way around. You could also think of it as four right angles, 90, 90, 90, 90. That adds up to 360. Okay. So that idea that the whole circle all the way around is 360 is going to be really useful to us. For example, when I look at this diagram here, I know that these four angles have to add up to 360 degrees. And I also know that these arcs, there's four arcs, 1, 2, 3, 4, they have to add up to 360 degrees. And that's going to become really important to us. Okay. So like we already said, the half circle is 180, right? So two of those put together is 360. Keep that in mind. It's going to be really important. Another thing that we know, that we've known for a very long time, but it comes up sometimes in circles, is that vertical angles are congruent. So remember what vertical angles are. That's where you see that crisscross, right? So it happens a lot when we have central angles, where I have angles coming together in the middle. Anytime you have an X like this, you have pairs of vertical angles. So this angle and this angle will be the same, and this angle and this angle will be the same. We've known that for a while. It's going to come up for us again in this section. Okay. Now, some new information from this section was the information that we have about central angles and about inscribed angles, right? So we know that if an angle is central, that it's going to cut out an arc. So for example, this angle right here is this angle right here is a central angle, right? We know it's 70 degrees. We were given that it's 70 degrees. If you follow the arms of the angle out, it creates this arc right here, arc AC. So we know that because it's a central angle, this arc, arc AC, is also going to be 70 degrees. When it's a central angle, the arc matches the angle. We also learned that when it's an inscribed angle, the angle is only half of the arc. In other words, because it came back further, the little kind of projection that it does out onto the arc, this is going to be a bigger arc than the angle. So if this is 30, then we double that. And this arc would be a 60-degree arc. Right? So you can think of it as the arc is twice as big as the angle, or you can think about it like the angle is half of the arc. Okay? The way I remember it is this. If this 30-degree angle was at the center, it would make a much smaller arc. It's because you took this vertex and pulled it back that 30-degree angle makes a bigger arc. It reminds me of like when you use a projector, right? If you've ever used a projector, the further you pull it back, the bigger the image gets, right? You're using a projector and you put it right up close to the screen, it's going to make this image this big. The further you pull it back, it projects out, makes a bigger image. That's what's happening with inscribed angles. If they're in the middle, they're making an angle that's the same as them. When you pull it back, it has more time to open up, and the arc is twice what the inscribed angle is. Okay, so when we look at a problem like this, for example, let's apply what we know here, right? If this angle right here is 70, then that means that the angle across from it, the vertical angle, also has to be 70. That can also help me figure out these angles, right? Because I know that a straight line has to be 180. So if this is 70, then this angle right here is going to be 180 minus 70, or 110. Well, if that one's 110, then the one across from it is 110. So this idea that vertical angles and this idea that a straight line makes 180 degrees is going to help us find all of those interior angles. Right? Since these are central, I could also figure out how big these arcs are. right? This arc is 110, this arc is 70, and so on. All right, so let's take a look at a couple problems and see if we can use what we know. All right, number one. Notice in this picture, we are given the center of the circle, and we have some central angles here, right? This 21-degree angle right here is a central angle. Its center is its vertex is in the center of the circle. So that little angle right there, JNK, is a central angle. Because I know it's a central angle, I know that the arc that it creates, I know that the arc that it creates, this arc right here, JK, is going to be the same as the angle. So if that's 21 degrees, then that arc, JK, is also 21 degrees. And that's one of the things they asked us. This little M stands for measure. So the measure of arc JK is going to be, whoops, I'm saying 70 like it's the last problem, 21 degrees. Okay, so let's go from there and see if we can pick this problem apart. You have a crisscross here, a perfect crisscross, right? So if this is 21 degrees, guess what? The guy across from it is 21 degrees as well. And that also means that this arc right here is 21 degrees. So let's see if it asked us either of those. Did it ask us for this angle, MNL? Nope. Did it ask us for this arc, ML? Nope. It asked us for arc KL. It asked us for JKM, that's another arc, and MKL, that's another arc. Right. So they didn't ask us for this little arc. Great news though. I can use it to find all the things they asked me about. Notice that all of these arcs they asked about involve these two pieces here. And I don't know what they are, but I can figure them out because I know that these guys are 21, right? So you can either use the 360 idea or you can use the 180 idea, right? Let's go with the 180 idea. On a straight line, this has to be 180 degrees, right? This part's 21. Let's figure out what this part is. That would be 180 minus 21. So 160, 159. So this angle right here has to be 159 degrees. So that means this arc is 159 degrees. They did ask us that. Look, measure of arc KL, 159 degrees. Okay. Now again, look, if this is 159, the angle across from it is also 159. So at this point, I know how big all the arcs are. So I should be able to answer the rest of these questions. So let's see here. The measure of angle JNM. JNM. Oh, look at that. We got it. It's 159. We already knew it. Okay. The measure of this is an arc, JKM. So arc J, go through K, so here, and then all the way around to M. Oh boy. All the way around to M. Okay, I'm going to get my highlighter out for this. So I want, oops. So we want this piece. So you want JKM. So that piece, and then keep on going all the way around to M. We want that whole big arc. So if we want that arc, all we have to do is add up its pieces, right? So let's see what its pieces are. This piece is 21. So from here to here is 21. From here to here is 159. And then from L to M is another 21. So if I want to know how long that big arc is, I can just add those three numbers up. I can say 159 plus 21 plus 21. So let's see, 9, 10, 11. 5, 7, 9, 10, 201. Okay, listen, another way to get at that. If you notice what I highlighted here, JKM, that's the whole circle but for this. So what if I just said, well, the whole circle is 360. Take away the 159 that's sitting there. That's the only part I didn't use. I could get my 201 pretty quickly that way as well. Right? So you can either add up what you have, or you can say, well, the whole thing is 360. Let's take out the ones we didn't use. That works too. Okay, so let's see. What about MKL? Oh my. I'm going to clean up my circle here, if you don't mind. So we can actually see what we're doing. Okay, so MKL. That's a lot of arc, right? I need to go from M to K, so M all the way around to K, and then continue to L. That's a big arc. It's almost the whole circle. Right? So again, you could do this two different ways. You could add up these pieces. This is a 159, this is a 159, and this is a 21. Or you could just say, look, I'm using the whole circle except for this little chunk right here. So why not just say, well, let's do 360, which is the whole circle, minus that one little tiny arc I didn't use. Right? So that'd be 343, 39. I think, for me, that's an easier way to get at it. Okay. All right, so take a minute and try one of these on your own. This is a central angle problem, just like the one we just did. Notice they gave you this 87. Here they gave you this 72. They told you it's the arc, but we know we can carry that measurement in. Okay. Again, use this idea. There's 180 degrees across a diameter. There's 360 all the way around. Go ahead and try those, and we'll take a look at them together. All right, we're back. Okay. Let's see what we have here. All right, so if we want to, I like to kind of mark up my diagrams first and then see if I can go over and answer any questions, right? So they told us this arc is 72, so I'm going to bring this 72 in here. Okay. Then let's see, look, there's a pair of vertical angles. So if that's 72, this is 72. And I should be able to figure out this guy because that's a straight line, right? 180 degrees. So if I take 180 minus 87, that's 93, and then minus 72, that's 21, right? Hey, another 21. That's 21. And then I could also get at this last angle down here by using the 180 thing, or we could do it by knowing that all those central angles have to add up to 360. Okay, so if I add all of these up, what's left out of the 360 has to be this angle. Another way you could do it is to notice that this angle here makes a straight line with the 72, so it has to be 180 minus 72. So 108. Once you have all the central angles, the rest of these questions are going to be really easy to answer because all we have to do is figure out which arcs we need to add together, right? Because all those central angle arcs are going to be exactly the same as, the arcs are going to be the same as the angles. All right, so let's see. First thing it asks for, the measure of UXV, angle UXV. So UXV, that's this angle right here. Look, we already got it. It's 72. All right. Then they want the measure of arc ST. So the measure of arc ST, here's S, here's T, that's a little one. That angle is 21, so the arc is 21. Okay, degrees up here. Okay, they want the measure of arc WV. So from W to V. Again, that's got to be the same measure of this angle, so 108. They want the measure of arc TW. Let me get my highlighter here. Okay, so TW, that's from here down to here. So for us, that means we have two pieces to add up, right? From here to here is 21, and then from here to here is 72. So we just have to put our 21 and our 72 together, so 93. And then last but not least, we want TVW. So T to V, continuing on to W, TVW. It's a big arc. So look, again, we could add 87, 72, and 108. That will do it, right? 108, 72 is 180, plus another 87. It's 267. The other thing we could do is say, you know what? This is basically the whole circle except for this little purple chunk here, and we already decided the purple chunk's 93. So if I take 360 and subtract 93, I probably don't have to tell you that I end up with 267. Okay? We know there's 360 degrees in the circle, so I can either get to this arc by adding up the pieces I know it's made of, or I can use the one I already have and do a subtraction. Either way, 267 degrees. Okay, so both of those problems involved central angles. The other, I want to also take a look at some that involve inscribed angles. Now, good news, the inscribed angle problems are usually a little easier, and notice that they're not multi-part. Okay, so look at this one. It says, find the measure of PQR, angle PQR. So, PQR. So this might be a little hard to notice. It just looks like a little bit of a silly diagram. PQR, this angle right here, this is an inscribed angle, right? Its vertex is right here on the edge. So PQR. So I do not know how big this angle is. That's the question. But I do know that however big it is, it should be half of the arc it created. So I want you to notice the arc it creates. If you go from P to R, where it hits the circle, it just so happens that from P to R is a half circle. It's 180 degrees. Notice that this angle touches on the ends of the diameter. So this arc is 180 degrees. Well, it's an inscribed angle. So if the arc is 180, that angle is 180. The angle is going to be half of that. The angle is 90 degrees. And look, it does really look like a 90-degree angle. Okay, so the inscribed angle ones, usually there's not as many parts. So here's one for you. In this one, we want the measure of arc BC. Now this one isn't as straightforward as the other one. You're going to have to do a couple steps, right? Because they gave you this angle, 47, but the arc they want isn't the arc that angle creates. It's this little chunk over here. Right? So take a minute and see if you can figure out what arc BC must be. Okay, I'm excited to find out if you got this or not. All right, let's see here. So let's start with what they gave us. They gave us that there is this, they gave us one particular angle here. Now again, it's an inscribed angle because its vertex is on the edge, right? So this little angle right here, this 47, it comes way out. It's like a projector angle, right? And it creates this arc AC. AC isn't going to be 47 because that's an inscribed angle. AC is going to be twice that 47. So 47 times 2, 94. Okay, so this is a 94-degree arc here. All right, now, how in the heck is that supposed to help me get to arc BC, which is the one I want? Because I know that the whole circle has to be 360, right? But I know something else as well. Notice in this picture, I'm not guessing. They put a diameter in this picture. So because this is a diameter, we know this over here, this whole thing has to be 180 degrees. So if I want to get to this arc, I just need to figure out what's left out of the 180. Right? So if this chunk is 94, what's left for this? I'm just going to do the 180 minus 94. So 66 degrees. There we go. Okay, so as you can see, the idea of central and inscribed angles comes in a lot to these problems, but even more than that, this whole idea of 360 degrees around and 180 degrees for a half circle is really, really important idea. Okay, any questions that you have on this, please put them at the end of the video, and we'll start taking a look at some problems. Bye.